Today I have a very special guest, Space Miner, who has his own channel also. So feel free to go over to his channel and subscribe. He's at a little shy of 900 subscribers. We need to get him to 1,000 so he can get monetization. Thank you very much, Space Miner, for coming to visit to my channel, especially for this very interesting topic.
Thank you for having me. I appreciate it.
Space Miner is a firefighter. The fella is highly educated, self-learned. When I saw him talk about osmium, I was highly impressed. I am so very honored to have you on the channel.
And I appreciate all the compliments, and I'll do my best to live up to expectations. But like I've told you, I'm a caveman that stumbled into a spaceship.
Let's find out about you. You're a firefighter. How did you get into osmium and all that type of stuff?
I'm just kind of a nerd, and I've always had a fascination with like raw materials and bulk materials. And I started element collecting, and osmium was always kind of like, one that you reach for with density. But then I discovered the crystallized osmium, and it just kind of became the king of metals to me. So I gathered a lot of interest in it rapidly because it just makes sense.
I'm kind of late to the scene. I had been buying precious metals from Ian Everard, the owner of Arc Silver Gold Osmium, who, by the way, is one of the nicest fellas I've ever met and one of the most honest fellas I've ever met. And then he's talking to me about osmium, and that's when I first heard about it. Now, me personally, my theory is that it's real. It's not a scam. And ever since the live stream Silver Dragons did, and then the subsequent live that I had with Silver Dragons, Ian and Barry, I've been interested in getting to the root of the matter, both from a journalistic and a scientific point of view. This is, of course, with anything scientific, you have to go in with a theory and prove or disprove that theory. And it has to be something that can be reproducible. But I'm also planning on doing it from a journalistic standpoint by talking with you and, God willing, others, and being able to prove or disprove. Outside of that, I am going to personally take more of a neutral approach to the subject until proven. But I did buy 2 pieces of osmium for my wife's earrings. She saw it and did the typical girl thing. As soon as I heard that, it was bought. So osmium, interesting element, number 79 in the pathway, if I remember correctly.
76.
76. That's right. 79. I think 79 is gold. It is atomically less dense than gold, but yet when you have the physical metal fleet.
No, I would like. Oh, there's a small correction real quick before we go on.
Yes.
It's actually the opposite of that. Gold has a greater atomic weight, but it is a lesser density. Osmium is the densest of all the elements. So all your
Then I found out why, because it has nothing to do with the atomic weight. It has with the overlap. The atoms overlap each other tighter in an osmium piece than it does in a gold piece. So subsequently, it's more dense.
right, which has to do a lot with your nucleus and electrons, and the fact that how many protons, how many neutrons, and then based on that weight, then you have your electron shells, and then your electrons gather up and they fill their shells, and it creates a super full atom. It's just an atom that's just packed full. It's just packed, and that's part of what makes it so dense.
Basically, the atoms are just tighter against each other than what gold would be, which might be one of the reasons it's not only stronger, but it's also has more resistance to manipulation, which is part of the lead-in that I have for how we go from the regular osmium to the crystalline form. So I understand it, the regular form of osmium has some risk factors to it. If it oxidizes, becomes osmium tetraoxide. Then if it enters into the human lungs, it causes a lot of damage in the lungs. So this is a substance you do not want to play with. In fact, I put it into the description down below.
In its raw form, in its sponge form, yeah.
As we talk about the science of crystallized osmium, I'm asking everyone, whoever sees this video live stream, do not attempt to do what we're going to talk about. First of which, neither one of us knows the actual exact formula for crystallized osmium. And I don't expect to. I don't expect the Osmium Institute to release it. Similarly, and analogous to goldbacks. They don't give out their formula. I don't expect the Osmium Institute to give out their formula. This is more of a basic scientific explanation. We don't want anyone hurt. We don't want anyone getting killed. Just accept the science. Otherwise, keep stacking and just understand what we're talking about. What do you say?
I say that is a wonderful disclaimer to make and a wonderful warning. And then when we start talking about crystallization, we are talking about deep vacuums, ultra high temperatures. There's a lot that can go wrong, materially speaking. I mean, just your equipment alone, not to mention certain effects of the process.
There was a video that you did where you talked about how the crystalline form actually formed. And as soon as you said it, my brain went right into understanding the basics. You talked about sublimation. Do you remember that video?
Yeah, my crystallization for cavemen. And this is also known as enthalpy of transition. Osmium has a pretty unique quality called sublimation, where it can go directly from the solid into the gas.
We're going to use another substance, not osmium, as an analogy. So, substance is water. Water, like all other components, usually has a gaseous, a liquid, and a solid state. This cycle is really not complete because there is a process called sublimation. Sublimation is where a substance that's a solid goes into a gaseous state and does not go into the liquid state. And the opposite is deposition, where it goes from the gaseous state to a solid without going into a liquid state. A lot of us might wonder what that might entail. Well, that could entail this frost. It forms its own crystals. No crystal is exactly the same. And when you get into your car, look at the frost from the inside before you melt it. Same thing I've noticed in airplanes. When I was flying airplanes frequently, I would notice that we would have frost on the windshield and get rid of it. But the interesting thing about wintertime is the clouds are more dense. They're not at feet raised as high. And when you go into the cloud, you will pick up ice or frost or both on your windshield and on your wing. Not all airplanes have the ability for de-icing, and we picked up a good bit of frost and ice on the windshield and on the leading wing, which does disturb the laminal airflow, giving you the Bernoulli's principle on lift of the wing. But knowing what I was taught, because they teach sublimation and deposition, when you become a pilot, I got to actually see the sublimation happen. The leading edge of the wing, once it was out of the clouds and air was passing over it, thereby creating partial vacuum. And also cold air has a tendency to have not as much moisture. So you lose the partial pressure in air, caused the frost to come off, leaving us with a dry wing, dry windshield, and you probably have seen in your home is you have ice in your freezer, and if you don't use the ice, it tends to get smaller. Well, why? Same reason. The freezer, you got cold air. Cold air is drier air, a partial vacuum for water. So it takes the water off of the ice, just basically sublimates it. Whether you have deposition, the forming of frost, or sublimation, the removal of frost and ice, that is a really good basic analogy for what I thought of when you said this about sublimation and deposition of crystallized osmium. Now that I've talked a good bit about water, I want to hand the mic over to you and let you talk about on that video.
Well, man, I think you pretty well captured it. And that's a great analogy. Ice, water, is one of our primary tools of measurement. We know it so well. It's common, it's room temperature, it's all that stuff, right? So all your metals do this too. All the way from sodium to osmium, they're all pretty much the same thing, atomically speaking. Pretty much they all have the same kind of an effect, right? Not every material out there will sublimate. What's neat about osmium is it's also a refractory metal, and you're going to find this fairly commonly in your refractory metals, kind of like ruthenium. The same way that this is happening with the water is the same way it's happening with our metals. We're just experiencing them from different temperature and pressure perspective. I guess if we wanted to go a step further, metals are strictly bound, like in crystalline lattices, and they're a lot more densely compacted. Their molecular bonds tend to be much greater than something like water's molecular bond. And so it can take more influence or energy through its phase changes. What ends up happening is to do this with some metals like osmium gets so hot, takes so much heat with osmium that we literally can't build the equipment to withstand it purely thermally. It's why we have to start affecting it with things like vacuum. So that's why we pull the vacuum to decrease the pressures. That's why I really like your analogy, you know, because these things under normal conditions, remember, like all of these sublimation, deposition, freezing, what we have to do is we have to move these materials like osmium, these high temperature materials like osmium, we have to move them out of these high temperature ranges because we can't get materials that can withstand the heat. Osmium takes an enormous amount of heat. And just for melting is a 5,491. You know, you take it higher in elevation, it boils quicker. And if you put water in a vacuum, what does it do? It vapors off. And a lot of our metals are harvested and purified under these types of conditions. That's how a lot of these metals are recovered in the first place. You know, we got to like phase change them in pieces and parts. So if you got like 2, 3 metals mixed in with each other, we'll just say they're all going to melt, they're all going to vape, and they're all going to boil, and they're all going to freeze at different temperatures and pressures. So if you
Correct.
reduce these pressures, it doesn't make as much heat. And so if one melts at a lower temperature than another one, then you only have to bring it up this much and you can pull off this material. And then you
Correct.
bring it up a little higher, like let's say a good vacuum, right? We're under a good vacuum. Bring it up a little higher, then the next metal can come out. Bring it up a little higher, now the next metal can come out. And now you've, in essence, processed these metals. And so when we're talking about recovering some of these ultra rare metals like osmium, a lot of it's done under extremely high temperatures and chemical emphasis. You have to change these conditions around it, you know, down to its molecular bond. You know, like you have like activation energies that are starting to be considered. You know, how far have you stretched its molecular bond? Because the further you stretch its little molecular bond, then it takes less energy to overcome it at the end of its grip. You know, you only need a little push instead of a big push.
Similar to what happens in your freezer with ice.
Exactly. And if you watch, you created like a phase region of a sort.
Exactly.
Mhm. Yeah.
So subsequently, what I see is when you were doing your video was in a vacuum environment, you have a gaseous osmium in a vacuum, ergo no oxygen, ergo no tetraoxide, and it's also a controlled environment. Then it comes to a surface, in this case, similar to a wing of an airplane, and it starts depositing. Similar to what frost will do, it starts making its own form of crystallization. That's my oversimplification, Bill Nye the Science Guy type of explanation. You get a flat surface on, but yet on the other side of the coin, you got your levels of crystallization, which tends to form in a hexagonal type of fashion. So that's a very interesting process. So this brings us to the end of the video. I hope that you have learned a lot about the crystallization of osmium and the analogy that I used with frost. Please leave any comments down below. Please like, subscribe, share with everyone for not only this channel, but also Space Miner. Tiger Stacker out.